Please give your introduction.
Our next lecturer took her postgraduate studies in neurology and psychiatry at Harlem Hospital, USA. She took her neurology postgrad studies at the Royal Free Hospital in London. Currently, she works at IELLIOS Limited in the United Kingdom and IELLIOS Inc. in the United States. Please welcome Dr. Sofra.
Thank you very much for inviting me, and we're going to be talking about a lot of things today that have to do with novel modalities, a number of different technologies. I have no conflict of interest, and this lecture has been based on my books that have been translated in 12 languages and 56 articles that I have authored, and of course hundreds and hundreds of references that are included in the articles. Now, the one thing that I want to start with that's very important is that you need to learn not to believe what's on print. And I'm going to go through all the things that you need to look out when you look at the research paper. And the number one is conflict of interest. Conflict of interest is when the company is paying for the research, and then what you need to know, if the article has the name of the machine or the technology cited, that article is being paid off. So it's a marketing article, it's not a science article. Another thing that you have to be very well aware is you need to check the data. I have seen a lot of articles that say we got 0.001%, and you look at the data and it just doesn't add up. It's like, actually, it's not even significant. So you have to look at the data. And once you look at the data is the percentage. So the percentage has to be, as you can see here, it has to be 5% chance that somebody will get that result, okay? So it has to be 95%. So I see articles and they say, well, 35% of the, we had 35%. 35% is not significant, it's not close to being significant. So that's a very important aspect that you have to look at. When you look at the study, you need to know the significance level of the study. Otherwise, that study is not scientific. The other thing is that you have to look at long-term results. They have to be, you can have a result today and then you have side effects much later. I'm going to talk about that when we're talking about stem cells and lysosomes, which is going to be shortly. So side effects, for example, of hyperpigmentation or ulcerations can come later on, and that's very, very important to know. Another thing to remember is animal studies. There is certain, like for hair, for example, when they have animal studies, because the hair is a more kind of complex effect, it's not, at the molecular level, we're all similar. So molecular studies, you can use animals. But when you start to use animals for hair, that is kind of more complex because the hair is a higher level of complexity. So it might not represent the results. And also, you need, again, to look at statistical significance. The other thing is what I call the emperor says no clothes. They say, look at this, we got one more hair. Well, one more hair doesn't mean much. It can be just random. So you have to look at, when you see results, how much is the result? Is it substantial? That's a study from radio frequency, before and after. You can see very, very little difference. The other thing is combined treatments. So this is a study that they combined minoxidil and the fractional laser without or with minoxidil. And they did find that the results were better, but the significance level was just not there. So that could be random, it could be just by chance. Now let's talk about hair. Why do we lose our hair? Number one is nutrition. There are things that are missing from our nutrition regimen. So one of those nutrition things are zinc, B12, and biotin deficiency. There's other vitamins, but the research has found those repeatedly, so they seem to be quite substantially related to hair loss and hair growth. Another one is metabolism. Now this is a very interesting one because as we're aging, metabolism is not at its peak. So that's why people lose their hair when they're aged, because the metabolic organization is deficient. The T3, the T4, all of those are substantially decreased with age. Now the most important, however, thing is inflammation. What is inflammation? Inflammation is equal to aging. When you have inflammation, not only you age, but you're more vulnerable to different diseases. So hair loss is very substantially related to inflammation. There's a lot of studies on this for both males and females. Actually, alopecia is very much related to inflammation. Alopecia is also related to stress, but stress increases inflammation. So hair loss and inflammation, there's a lot of studies even with like irrelevant things like inflammatory bowel disease and other things, and you see that people, because of the inflammation of the bowel or other inflammatory processes, they lose their hair. Now, inflammation causes hair loss, and we use radiofrequency to increase hair. However, there is a lot of studies that have shown that radiofrequency is associated to inflammation. Not only inflammation, it's also associated at the molecular level in denaturing proteins. What does that mean? Denature means destroy. A protein, if it is denatured, is useless. And proteins are the brains of the cells. So you don't want to destroy that part. So this is the process of denaturing a protein. Basically, it loses its structure, and the structure of the protein determines its function. So the denatured proteins, you don't want to do that. It's what can cause aging, it can cause diabetes, it can cause Alzheimer's disease, senility, and all kinds of other different problems. Now, what is that? Now, you know an egg, right? An egg can produce a chicken. Chicken comes out of the egg. But when you fry an egg, this is what is the denatured proteins. The problem with having a protein that is denatured is that the signals of these proteins affecting the proteins around it, and then you have like a bunch of fried eggs instead of having, which basically cannot produce life, they cannot produce communication. The communication in that area is disturbed. So this is how significant is when you have a protein that is denatured. But what is radiofrequency and lasers good for? They're very good for hair removal. And actually, 15 out of 19 studies in a review paper showed that most of these papers are targeting hair removal. So hair removal is something that is, they are very efficient and very good to do so. And this is a study that shows a very basically efficient hair removal with ruby laser. Now let's talk about stem cells and hair growth. And there's a lot of companies that are using stem cells for growth, for hair growth. And you have, of course, the embryonic stem cells, and you have the mesenchymal stem cells. And the mesenchymal stem cells are more preferable because they don't have the ethical issues, and basically they do not have the problems that the embryonic stem cells have, which is the tumorigenesis, basically creating tumors. So what happens, what is the main problem with embryonic stem cells is that because they are undifferentiated, what is the difference? Differentiated means it has become a functional cell. It has become a liver, a heart, a hair in the case of the hair growth. But if it's not differentiated, if it's undifferentiated, then it can create tumors. And the embryonic stem cells have a tendency to kind of increase their differentiation, undifferentiation, and create teratomas. So there are, now the other problem is that where you get the stem cells from. So at the post-tissue stem cells, there is a lot of papers that, like this paper over here, that shows that white adipose tissue cells are created by tumors and they promote the hair growth and the malignancies. Now you have the mesenchyma stem cells, but however, the mesenchyma stem cells have a problem with cellular senescence. Basically, when you get older, the mesenchyma stem cells, they start having an uncontrolled proliferation that again can create tumors. And the most important thing about stem cells is immunorejection. So a transplant of stem cells is not going to be accepted by the immune system, it's going to be rejected, and if it's rejected, it won't differentiate, and then you're going to have the other problems. So, and that's going to be even, like if you transplant a heart, it's probably the body is going to accept the heart much more easily than accepting a transplant of stem cells. So immunorejection is a very, very big problem. They have a lot of bypassing the immunorejection now by kind of stopping the immune system, but then they get the problem of that if the immune system is not alert, you could have other problems that can happen in the meantime. Let's talk about the exosome miracles. Now, there's a lot of, all over Europe now, they keep injecting exosomes, for hair growth, for cellular regeneration, for skin repair, etc. But that's an double-edged sword. Why? Because of, okay, let's start with what the exosomes are. Exosomes are basically the cellular communicators in our system. They have a role in spreading proteins, they carry mRNAs, they carry microRNAs, they have long-coding RNAs and DNAs. Basically, they are the transfer, as we're going to talk about later, it started from the Nobel Prize 2013 that they found that there is a communication, there is a transfer of communication from one cell to the other, like you have FedEx and DHL and the post office. This is what exosomes are. They transfer the information from one place to another. It's very important because they can use it for drug delivery, they can use it for vaccines, etc. However, they can also carry the wrong signals. They can also be utilized by cancer cells that you have in your system to kind of increase the communication between cancer cells and therefore increase malignancies. So it's about 50% good and 50% bad. So that's something that you have to kind of be very careful about when you are injecting exosomes. The other very interesting thing is that they carry a diverse cargo of proteins, nucleic acid and lipids, and they can be delivered for therapeutic or for pathogenic purposes. So although exosomes therapy is becoming very popular, you have to be very careful because there's still not enough evidence. There are not enough clinical studies about them. So now we have another technology that's the red resonance energy transfer technology, and that's very interesting because it basically, as you can see, there is a transfer of energy between the cells, and it's happening with resonance. Resonance is a process of amplification. So you basically have a resonance process and everything is amplified. The whole system is awakened. And this is the Foster resonance energy. This is what it does. As you can see how it increases the signal. You can see on the B2 and C2 how everything is increased, and that can increase the signaling process, can increase the health of the system and the hair growth and also the skin repair. And here is under the microscope, you can see how this is expanding, the signal is expanding and is transferred. This is another one, you can see how it expands and it's transferred again under the microscope. And this is a chain reaction of different nerve cells, that nerve cells, how it expands. And that's again how an older system that has been declined, how it can be rejuvenated, it can be reawakened. This is a microscope, and how you can see the resonance transfer. You see how the cells is getting elongated and it sort of transfers its energy. And this is how you can sort of combine different frequencies to create the signals that can sort of transfer to different cells. And this is how you put the waveforms together. There is a kind of proprietary things. So how you can communicate, you can create a device on the outside to communicate with the system inside and amplify the set. And we did use some of this technology in London University, and we created, it was for hair. And you can see in one treatment, his hair started immediately responding, it kind of was standing up. And then there was significant increase of the hair that you can actually see. You don't have to kind of go with a microscope, you can actually see. And this is after the third treatment, and after the fourth treatment, and that's after the fifth treatment. So you could see substantial hair growth with this technology. This is a different technology, similar, that's a red, resonance energy transfer again. And again, another one, 4 treatments after 3 months. And this is only 1 week. You could see a little bit of improvement. That's a whole different technology again. And let's talk about skin disorders. Again, number 1, the most important thing is inflammation. So this is what causes all the problems, inflammation. So there is persistent inflammation underlies abnormal skin healing. And you can see inflammation is present in adults, but not in children, that they don't have inflammation. You can see that. There's no scars. When the children have an accident, there's no scar. Why? Because there's no inflammation. So the scar formation is due to inflammation. And there is a depletion of one or more of the inflammatory cell lineages that's enhanced, and you don't see the wound heals much faster when one of the lineages of inflammation is stopped. And of course, chronic inflammation is the result of all wounds that cannot heal. And we have a lot of lasers and RF trying to deal with skin repair. And the main question, what they say is they increase collagen. But let's talk about collagen now. Collagen is the star of laser and RF, the trauma-based anti-aging. However, scars are made of collagen. Okay? And the most important thing that you need to know is that collagen is 1 out of 100,000 proteins in the human system. So rejuvenation cannot be just based on protein, on collagen. It has to be based on what we call proteostasis. In other words, not only all the other collagens, but the balance between all these other collagens. Now, collagen, there's about 7 collagens in the human skin. So again, when you have a paper and they say they increase collagen, the question you need to ask is which one? Because it's 7 of them. And all 7 of them have to be involved to have skin rejuvenation and skin healing. The other thing is that only in the epidermis you have 8,987 proteins in the stratum corneum, and you have 9,140 proteins in the inner epidermis. So you have about 18,127 total proteins, not just collagen. So this is another question you ask. Oh, okay, you increased collagen. What else did you increase? How many other proteins you have increased? Because you need to increase a lot more proteins before you have both healing of the skin or rejuvenation. Now, the other very important thing is that young people have a lot of ability to create collagen. Older people don't. So when you say you're increasing collagen, if somebody, because the trauma will increase the collagen, but if the skin does not have the resources to produce the collagen, no matter how much trauma you do, the skin is not going to produce anything because it doesn't have the capacity to do it. As you can see, the young and the old have very different resources of collagen production. Now, the other question is, again, side effects and how long does it last and what has happened basically. So lasers are safe and effective until they're not. So there are a lot of underreported effects between lasers and RF. And of course, there is one of the dangers is the repeated skin trauma that creates the granzyme B that creates more apoptosis, and in the end, basically don't have anti-aging, you have aging as a result of the trauma procedures or repeated trauma. And again, now let's talk about stem cells and healing, and we have the good, the bad, and the ugly. The good is that yes, it does help in certain aspects. The bad is that immunorejection, we spoke about it before, the immune system will reject the transplant, and then we're going to have many problems, and then it goes into the ugly part, which is the formation of tumors or cancers. And you have exosomes. This is the Nobel Prize 2013 from Rothman. They basically discovered there is a transfer of vesicles that kind of transfer information. This is what exosomes are. So it's 2013 and still that it boomed and everybody started talking about exosomes and they're going to use it here and there. The problem with the most important exosome, especially for the skin, is the calling RNAs, and they are involved in gene expression. And the most important thing about gene expression is that in the young and in the old, it's different. So what you see here is you see the young in the blue to red, okay? And you see in the old from the red to blue. So one is increased response and the other one is decreased response. So the same exosome can create an increased response, it can be positive, or it can cause a decreased response. In other words, it can be deleterious or compromise the system, depending on whether the subject is young or old. So that's another thing that you need to understand. It's not just, let's take an injection and stick it into somebody's skin. You have to take into consideration a lot of aspects of this, and we're not ready yet to have all the data to make this a safe thing. Now, there is other research that talking about ionic currents, that they increase healing and increase secretion of growth factors, and this is the pictures that came from this study. That's another technology, and they also, more studies, there's from Dr. Lee and Dr. Wandel, whom I actually met in some conferences, and they're talking about permanent healing, the very impressive results before and after with ionic currents, and how this, because actually the healing is, if you see Nuticelli studies, they show that there is healing internally. There is actually currents that reinforce the healing. inside our bodies, like that's a natural, endogenous currents that happen. And what their theory is, that is the technology acts as a mega antioxidant, because at the cellular level you have time reversal and anti-aging. You have this antioxidant, basically a free radical is a molecule that's missing some electron. So basically it donates electrons. As a result of donating electrons, that free radical becomes a stable molecule. So these ionic currents, they're donating electrons, and through that is a mega antioxidant process, and that's how they're explaining their healing that they see kind of clinically. And another, of course, we spoke about the resonance, how the tenor's voice kind of breaks the glass. This is what resonance is. Basically, it increases and has a very substantial effect. And again, the FRET, the Foster Resonance Energy Transfer, we spoke about it before when I was talking about hair, and you can see how it elongates and transfers the energy and creates a process. This is under the microscope. What you're going to see here is extremely interesting. You're going to see the cells communicating through the distance without any connection between them. So you see how they're communicating through the distance. This is a fascinating thing. It's like they're psychic. It's like when we are communicating from here to New York kind of thing, and there is a sort of a psychic process. And that's again a DNA repair, a press release from another Nobel Prize 2015, and they found that you can actually, when the protein is unfolded, there are certain ways of folding the protein through resonance and through this resonance energy transfer process that we're talking about. So you can have skin disorders that can be reversed by refolding the proteins. You can actually unboil an egg or unfry an egg through protein folding. And how they do that, there is several scientists have succeeded in folding proteins through this plasmon resonance and other techniques they're using now. It's a very new technology, obviously. And there's a measurement test that is called the second virial coefficient, SVC measurement, that you can actually see whether your technique of refolding proteins has been successful, and the level of success can be measured mathematically. Now, this has to happen at energies below thermal noise, so basically you can feel nothing. It's a very, very delicate technology. And at those energies, there is a book by Ruston. He showed that at those energies, for some reason, the cells open up, and then we can insert signals and electrons through there for this omega antioxidant process, which is why Dr. Lee and Wandel are talking about, when they're talking about ionic currents, because their energies are nanocurrent and very, very low. And basically, like keloids, that's overproduction of collagen, is miscommunication between cells. It's a communication that is basically overproduces collagen, and therefore it doesn't kind of give you the correct process. So a disruption of circadian rhythms and communications is creating a number of things, including psoriasis and keloids. And this is the Nobel Prize in Physiology and Medicine, 2017, where they basically looked at, they said that the cell is a circadian rhythm, and when that is disturbed, that's where is the beginning of disease, like skin disorders and other diseases that can be created as a result of that. So the timing of the cell, every cell has its own timing, and that is also has to be considered. So it's not just the refolding of the proteins, the timing. It's like a choreography. It's like a musical composition. So the same signal emitted at different times can have a different meaning. So that's another complexity, another level of complexity, the time issue, to add in all this how rejuvenation and healing can be created. This is a paper that I wrote with Dr. Lampe.